Welcome to this video on straight lines, the architectural grammar of 2D space. We will explore the fundamental concepts of analytical geometry. The year 1637 marked a paradigm shift. René Descartes introduced the coordinate plane, bridging the gap between algebra and geometry and giving birth to the field of analytical geometry. Our point toolkit allows us to measure, divide, and enclose space. A critical rule to remember: if the calculated area of 3 points equals 0, they are collinear, meaning they lie on the same straight line. The slope, or gradient of a line, is the tangent of its inclination angle. Note that lines parallel to the x-axis have a slope of 0, while lines parallel to the y-axis have an undefined slope. We derive the slope from coordinates using the ratio of rise over run. This universal rule holds true regardless of whether the inclination angle is acute or obtuse. For lines on a plane, their relationship is determined by their slopes. Parallel lines have equal slopes, while the slopes of perpendicular lines are negative reciprocals of each other. When lines intersect, they form angles. By convention, we use a master formula to calculate the acute angle between them. Once found, the obtuse counterpart is simply its supplement. A straight line contains infinite points. To define a specific line, we use different algebraic tools depending on whether we have points, angles, or intercepts. The simplest baselines are horizontal and vertical lines. Depending on your available data, such as anchor points or intercepts, you can choose from various equation forms, including point slope, 2-point, slope intercept, or intercept form. The general equation, ax plus b plus c equals 0, serves as a universal format. Any specific line equation can be converted into this form to reveal its underlying data. To measure the distance from a point to a line, we use a specific formula. We simply plug the point's coordinates into the line's general equation, normalized by the coefficients of the line. Similarly, we can measure the distance between two parallel lines. Because they share the same slope, the distance is a function of the difference between their constant terms. In conclusion, coordinate geometry provides a complete toolkit for 2D space. Every formula is merely a different lens for viewing the same fundamental geometric truths.